be stored at a facility at Edinburgh University, where researchers can help to collect and filter information to make it available to astronomers. Professor Andy Lawrence is part of the team, and he explained how the university is playing a key role in the 10-year study.
Edinburgh leads a UK consortium of astronomers that are involved, so there are people all over the UK. But the special UK thing is the big computers, big data, which is what we love in Edinburgh. So we're taking a copy of the huge amounts of data as it builds up, storing it here in Edinburgh and serving it out to astronomers to try and do science with. But especially also all those little things that change and go bang in the night, they come across to us. There's a deluge of alerts, little beeps saying something's happened, and it's too much for individual astronomers to deal with. So we have a system here that absorbs that stream, processes it, filters it, and then we have a website that astronomers go to and search it and analyze it in their own way, and that way they can finally get the science out. So that's it. We love big data and big computers here in Edinburgh.
And what is it that you're hoping to see?
Well, lots of things. And we don't quite know what it'll do over 10 years, but I'd pick out three things. Firstly, all those images, repeat images, you can stack them up and get deeper and deeper and deeper. So a lot of astronomers want that. They just want the very deep picture. They do things like trying to map out the dark matter and the dark energy and to understand that better. But the things that change, there's two things. Things that move have to be very close to us. So that's how we spot killer rocks, basically, asteroids and small lumps of rock that are very close to the Earth that could possibly be in danger of hitting it. So we want to map out where all those are. The third thing, things that go bang. Well, a lot of things change, surprisingly. I think people think of the universe as a slow, graceful place, and mostly it is, but there's things that change. So my personal favorite, for instance, is big black holes in the center of galaxies. When an unfortunate star goes too close to the black hole, it can get ripped apart and eaten up. And then the black hole briefly leaps into life and is very bright. It goes up in a few days and then fades away over a few weeks. And that way we're going to learn a lot about how black holes actually work and how they accrete matter, how the energy is made, and so on.
And what do you think it could teach us about the universe and life?
Yeah, well, protecting life, and that's what, the killer rocks thing is all about. We really want to know if something is going to hit the Earth and have some early warning. Although you think this is pure curiosity now, you never know what's going to be of huge practical importance. So, the classic example is electricity. When Michael Faraday was first experimenting with electricity, people literally said to him, "What's the point of this? It's useless, isn't it? Electricity," okay? And that took a long time, but it ended up transforming society and all our everyday lives. So when you study the universe, you're really studying physics, you're understanding just what makes the universe tick, and you really never know what's going to have a huge impact.